On the 1st of March 1982 at 3:57 a.m. Universal Time, a Soviet spacecraft called Venera 13 touched down on the surface of Venus. It was designed to survive 32 minutes. It survived 127. In those extra 95 minutes, the time it was never supposed to be alive, it photographed the surface. It analyzed the soil. It recorded the temperature, 457 degrees Celsius. The pressure, 89 times that of Earth. And it recorded something else. Sound. The first acoustic recording ever made on the surface of another planet. Soviet scientists analyzed it for months. They named the parts they could explain. Atmospheric pressure waves, wind shear at surface level, particulate movement across basaltic rock. But there was one portion of the recording for which they could not find the right word. And there were photographs taken during those extra 95 minutes that a senior Soviet scientist spent 30 years re-examining. When he finally published his findings in 2012, the Russian Space Agency issued no official response. They still haven't. This is not a story about what the Soviet Union found on Venus. This is a story about what they found and could not name. Why Venus? The Americans chose Mars. The Soviets chose Venus, a planet that burns at 460 degrees, where atmospheric pressure would crush a submarine, where it rains sulfuric acid. They sent 28 spacecraft over 30 years, more Venus missions than any space program in history. Why? What drove them to keep going, through 15 consecutive failures, toward the most hostile world in the solar system? What did Venera 13 actually capture in those 95 minutes it wasn't supposed to be alive? And why, 30 years later, did the most senior scientist of the entire Venera program go back to the photographs and use words like black flap and scorpion? Because he couldn't find scientific terms adequate for what he saw. Here is something most people don't know about the space race. It's a story that has been overshadowed, a chapter quietly torn from the history books. When we talk about the race to the stars, we almost always talk about the moon. The narrative is simple, clean, and satisfying. The Americans, driven by a spirit of exploration and national pride, planted their flag on the lunar surface. And that part is true. They won the moon. But the solar system is a vast place, with more worlds than just our own satellite. What the history books so often leave out is what happened everywhere else. They omit the other races, the other finish lines, the other victories. Because on the second planet from the Sun, on Venus, the story is completely different. On Venus, the Soviets won. They won completely, comprehensively, and for a long time, without any real contest. This wasn't just a single victory. It was a decades-long campaign of conquest against an alien world. Between 1961 and 1984, the Soviet Union didn't just dabble in Venus exploration, they committed to it with an almost religious fervor. They launched an armada, 28 spacecraft, each one a testament to a national obsession. This was the Venera program, arguably the most ambitious, relentless, and punishing planetary exploration program in human history. And the most astonishing part? For years, almost nobody in the West even knew it was happening on this scale. The story, like so many tales of great achievement, begins not with a bang, but with a series of deafening silences. It begins with a string of failures, each one a lesson written in the cold vacuum of space. Venera 1, launched in 1961, was a historic moment. The first human-made object ever sent toward another planet. It was a ghost ship, losing contact with its creators just 7 days into its journey. Venera 2 followed, and it too fell silent. Then came Venera 3, which achieved a grim milestone. It became the first probe to impact another planet. It struck the surface of Venus, a dead piece of metal that transmitted nothing back. In the West, a space program that fails 3 consecutive times on the same target is considered a disaster. A rational program, guided by budgets and public opinion, pivots. It changes course. it looks for an easier win. But the Soviet Union, forged in a different crucible of ideology and engineering, did not pivot. It did not flinch. It doubled its investment, pouring more resources, more minds, and more political will into solving the Venus problem. In 1967, their persistence paid off. Venera 4 launched, and this time, it worked. It was the first spacecraft to enter Venus's atmosphere and transmit data directly from within the clouds of another world. Scientists had hoped to find a sister planet, perhaps with warm oceans and a tropical climate. What Venera 4 found was a vision of hell. The atmosphere was a crushing 90 times denser than Earth's. The surface temperature was a staggering 485 degrees Celsius, hotter than the melting point of lead. And the clouds weren't water vapor. They were droplets of sulfuric acid. The data was unambiguous. Venus was not a paradise. It was a furnace, a pressure cooker, a poison world. The Soviets read this data, processed the brutal reality of what they were trying to do, and they kept going. The new data didn't deter them. It informed them. They understood they weren't building a spacecraft anymore. They were building an armored bathyscaphe, a deep-sea submarine designed for an ocean of superheated gas. They engineered their probes to withstand forces that would instantly crush a conventional spacecraft into a metallic pancake. On December 15, 1970, this new philosophy was put to the ultimate test. Venera 7 descended through the acid clouds and crushing pressure, and for 23 agonizing minutes, it sent back a weak but steady signal. It became the first spacecraft to successfully land on another planet and return data from the surface. It confirmed the brutal conditions, a world even more hostile than they had imagined. It was a monumental achievement, but it wasn't enough. The numbers were one thing, the data was stark, but the Soviets wanted to see it. They wanted to lay human eyes on the landscape of this alien world. 5 years later, they got their wish. On October 22, 1975, after surviving its own fiery descent, Venera 9 deployed its camera. It transmitted the first photograph ever taken from the surface of another planet. The image that slowly materialized in a control room half a solar system away was haunting. It was a vision of a primeval world. Sharp, angular rocks, unbroken by erosion, were scattered across a barren plain. It was a landscape that looked freshly made, as if the planet had just been reset, its surface wiped clean by unimaginable heat and pressure, waiting for its first visitor. Venera 13 was, in many ways, the culmination of a decades-long obsession. It was the most sophisticated, most robust planetary lander ever constructed by human hands. A marvel of engineering, designed to withstand a hellish environment that had crushed and melted its predecessors. It was a hermetically sealed sphere, a tiny bubble of Earth's environment, packed with scientific instruments. And for the very first time, it carried microphones. After sending so many probes to see Venus, the Soviets were finally going to listen. They were going to record the sound of another world. On March 1, 1982, after a 4-month journey from Earth, the moment of truth arrived. The descent vehicle, a 1-ton sphere of titanium and insulation, separated from its orbital bus and began its solitary plunge. It hit the upper atmosphere at over 11 kilometers per second, transforming into a man-made meteor. For nearly a minute, it was engulfed in a sheath of plasma, enduring temperatures that would vaporize steel. Then, the parachutes deployed, beginning a harrowing, hour-long descent through the thick, soupy atmosphere of carbon dioxide. The pressure outside mounted with every meter, crushing inwards. The temperature soared. Finally, at 3 hours, 57 minutes, and 21 seconds, universal time, it hit the surface. The timer began. The mission was on. Immediately, the lander's system sprang to life, a frantic race against its own destruction. The cameras activated, the microphones activated. The drill extended to sample the soil. Every second was precious. The engineers who built it had designed it to survive for 32 minutes. They hoped for an hour. The photographs Venera 13 transmitted back to Earth are among the most extraordinary and haunting images in the history of science. They are our only true windows onto the surface of Venus. The sky, not the black of space or the blue of Earth. It was a deep, heavy, suffocating orange. The ground, not sand or dust, but plates of flat volcanic bedrock, cracked and angular as if shattered by immense pressure. There is something deeply unsettling about those photographs. It's not because they show something utterly alien. It's because they show something almost terribly familiar. It looks like a rocky desert on Earth, a place you could almost imagine walking, but you can't. The air would crush you, the heat would cook you, the acid would dissolve you. That gap between the familiar and the fatal is what makes Venus so psychologically disturbing. It's a place that looks like home, but works like hell. And then there was the sound. The probe carried an instrument called Groza, designed to record acoustics and measure wind speed. Based on the thick atmosphere, scientists expected to hear a tempest, howling, roaring winds tearing at the lander. They braced for a cacophony. What they got was near silence. The wind on Venus, at least at that location, at that time, was a mere whisper. A breeze slower than most people walk, between 1 and 2 miles per hour. The surface of Venus was almost unnervingly still. The primary sound was the lander itself, the whirring of its cameras, the thud of the drill penetrating the rock. But the Groza instrument also recorded something else. Buried in the data, beneath the sound of the wind and the lander's own machinery, were other noises. A series of low-frequency pulses, repeating every few seconds. They didn't match any known atmospheric phenomena, and they weren't generated by the lander itself. Soviet researchers cataloged them, giving them a name: seismic micro-events. They theorized it was the sound of low-level geological activity, tiny tremors in the planet's crust. It was a reasonable explanation, except Venus has no confirmed tectonic activity. Unlike Earth, its crust is thought to be a single solid shell. So what was making the noise? The name seismic micro-events doesn't actually explain it. It just gives a label to a mystery. It acknowledges that something was happening, but we still don't know what. Venera 13 survived for 127 minutes, more than 4 times its design life, before it finally succumbed. For 30 years, its data was analyzed, its mysteries debated. Then, in 2012, a senior scientist from the original mission, Dr. Leonid Ksanfomalidi, re-examined the Venera 13 images with fresh eyes and modern processing techniques. He was looking for anything his team might have missed in the frantic initial analysis. He found something. In a sequence of photographs taken minutes apart, he noticed objects that appeared, moved, and disappeared. The first, a dark, flat shape about a foot across, was clearly visible in one frame, seemed to have shifted its position in the next, and was gone entirely in a subsequent one. Dr. Ksanfomalidi called it a black flap. The second object was stranger. More complex, with a distinct structure, it resembled a terrestrial arthropod. He called it a scorpion. Not because he believed it was a literal scorpion from Earth. He used the word because he did not have a better one. The shape defied simple geological explanation. It appeared, and then it, too, was gone. Ksanfomalidi published his findings in a peer-reviewed scientific journal. His conclusion was direct and world-shattering. The objects changing locations and their disappearance from view allow us to make a suggestion about their nature. What if we forget about the current ideas of the non-existence of life on Venus? Let's boldly suggest that the object's morphological features would allow us to say that they are living. The Russian Federal Space Agency issued no official response. The scientific community was largely skeptical, proposing explanations from camera noise to pieces of the lander itself. But the paper is still published, the objects are still in the images, and the question hangs in the air: unanswered. Imagine you are Venera 13. You have just landed. The surface temperature around your housing is climbing past 400 degrees. The atmospheric pressure is stressing every joint in your structure. Your designers gave you 32 minutes. You have exceeded that by an hour. Your cameras are rotating. Your microphones are recording. The landscape in front of you is orange-red, volcanic rock, flat, extending to a horizon you can barely see through an atmosphere thicker than deep ocean water. The sky above you glows a sickly amber from sunlight filtered through 20 kilometers of sulfuric acid cloud. It is noon on Venus, but it looks like the moment before a storm ends, when the light is wrong. Something is in the audio feed you are transmitting. Something your sensors registered but were not designed to categorize. You take photograph 13, then photograph 14. Something in frame 14 is different from frame 12. You transmit it. Your internal temperature reaches its operational limit. Your signal ends. Everything you recorded, 127 minutes of sound, 14 photographs, chemical analysis of the soil, arrives on Earth. Scientists begin the analysis. They name the parts they can. 30 years later, one of them is still looking at photograph 13, still looking for the right word. Venus is still there, and Venera 13 is still on it. It didn't burn up on entry. It didn't vaporize on the surface. It didn't fall silent after its designed 32 minutes of life. It sits, a silent monument to an ambition that once reached across the solar system. At 457 degrees Celsius, a temperature hot enough to melt lead and zinc, the metals it was made from are solid. The lander's pressure vessel, a marvel of Soviet engineering, is forged from titanium. Its landing gear from steel. They don't melt at those temperatures, they endure. Somewhere on a vast, flat plain of volcanic rock east of a highland region named Phoebe Regio, at coordinates 7.5 degrees south, 303 degrees east, there is a machine built by human hands, sitting on alien ground. It has been there since March 1st, 1982. For over 4 decades, it has been the sole, silent witness to the crushing reality of another world. No one has visited it. No subsequent spacecraft has photographed its resting place from orbit. No mission has ever been sent to find it, to check on its condition, to see what 4 decades in hell has done to it. The political landscape that sent it there has vanished. The Soviet Union collapsed just 9 years after Venera 13 transmitted its last signal. The brilliant engineers who conceived of it, who built it, who held their breath in a control room outside Moscow, they are mostly gone. Their knowledge, their memories, their triumphs have faded into history. And Venus, with its crushing 92-bar pressure, its sulfuric acid clouds, its perpetual suffocating orange sky, and its 457-degree surface, keeps it. What was once a precision instrument, a vessel of discovery packed with cameras, drills, and microphones, is now simply metal, an artifact. It is slowly, inexorably corroding in an atmosphere that was never meant to be survived, an environment that actively works to dissolve anything foreign. We sent something to Venus. Venus kept it. The last spacecraft to touch its surface, Venera 14's sister probe Vega 2, landed in 1985. Since then, for nearly 40 years, no human-made object has touched the ground of another planet closer to us than Mars. Venus has had no visitors. It remains a locked room, and we have misplaced the key. And then there is Venera 14. Just 4 days after Venera 13 made its historic landing, its twin, Venera 14, touched down 950 kilometers to the southwest on another stretch of basaltic plain. It was a staggering achievement, landing 2 complex probes on another planet in less than a week. It, too, carried a Groza microphone, hoping to capture the sounds of this alien world. It, too, defied its own design, surviving for an astonishing 57 minutes in the inferno. Its soil sampling arm, a spring-loaded device designed to test the planet's surface, extended as planned. It pressed down onto the ground below, a crucial experiment to measure the compressibility of the Venusian rock, and it measured it incorrectly. Why? Because one of the lens caps, a simple petal-shaped protective cover automatically ejected from the camera moments after landing, had fallen directly in the path of the sampling arm. Venera 14's one-shot compressibility experiment, a test designed to tell us about the fundamental geology of Venus, to measure the hardness of its ancient rock, ended up measuring the hardness of its own lens cap. Think about that. In the 127 minutes that Venera 13 survived, and the 57 minutes that Venera 14 survived, on one of the most hostile surfaces in the entire solar system, these Soviet spacecraft recorded sound, photographed an alien landscape, analyzed rock composition, and survived nearly 4 times their designed lifespan. And one of them, in its final heroic moments, accidentally measured its own garbage. There is something deeply, uncomfortably, and beautifully human about that. We build these magnificent, intricate machines. We pour our hopes, our intelligence, and our resources into them. We send them to impossible places, to the very edge of what physics and engineering will allow. We push them beyond everything we designed them to survive, asking them to be our eyes, our ears, our hands in the great unknown. And sometimes, at the very end, after overcoming every cosmic obstacle, they make a simple, almost comical mistake. They measure the wrong thing. And the most poignant part? We don't find out for years. Not until long after the mission is over, when some curious scientist, decades later, goes back through the faded data printouts and the archived telemetry and pieces together the quiet, ironic truth of what really happened. It's a message in a bottle, telling a story of triumph and failure all at once. The Soviet Venera program is officially one of the greatest achievements in the history of space exploration. 16 successful missions to Venus. The first photographs from another planet's surface. The first soil analysis. The first sound recording of an alien world. These are the things science named, but in every record from Venera 13, there are also the things it couldn't. A sound described as seismic micro-events, but not explained by any known model of Venusian geology. Objects given descriptive labels, black flap, scorpion, that are not scientific terms because no scientific term existed. A paper published in 2012 that asked the most specific version of the oldest question in astronomy and received no official answer. The Soviet Union sent 28 spacecraft to Venus, not to Mars, not to the outer planets, to the closest, most hostile, most uninhabitable world in the solar system. Maybe they knew something. Maybe they only believed something. Or maybe they simply kept going, the way you keep going when you found something you can see but cannot quite name. There are things in this universe that science has observed, analyzed, recorded, and then named. Not because the name explains them, but because naming them is how you acknowledge they exist while you keep looking for better words. Venera 13 survived 127 minutes on Venus. What it found has a name. That name is not an answer. 30 years later, the most senior scientist of the Venera program was still at his desk, still looking at photograph 13, still reaching for a word that the Russian language and the English language and every scientific vocabulary he knew didn't quite contain. Black flap, that's what he called it, because it's the closest he could get.